Solar energy is quickly becoming Europe's #1 power source. But here's the twist. Right around midday, there's often too much solar power on the grid. Prices even dip into negative territory, and sometimes plants have to be shut down temporarily. So what's the fix? PV hybrid power plants. But what exactly are they? How do they smooth out generation spikes, and why should anyone invest in them? Let's break it down. This June, solar power hit a record high, 22% of Europe's electricity mix, ahead of nuclear and wind. Coal? Barely 6%. Sounds like great news, right? Well, yes and no. At noon, the grid is flooded with solar power, wholesale electricity prices go negative, and plants are forced to curtail output. Last year alone, Europe logged more than 4,800 hours of negative prices, almost twice as many as the year before. To handle these fluctuations, the European Solar Association SolarPower Europe suggests combining PV plants with battery storage and wind turbines, so-called PV hybrid plants. Catarina Augusto, who co-authored a recent report, is convinced hybrids are essential for solar's future.
They are necessary. So let's say we are already answering with the need of solar growing, answering to what Europe needs in terms of the decarbonation of the system. But for that to continue in terms of integration of renewables, we need storage to be coupled with PV, and that's with hybrid systems. So they improve the way that energy flows into the grid. They also create less costs for system operators and developers, so that's the best solution. It's solar together with storage. We can also have solar together with wind and storage, but we are starting this as starting to create a more base load kind of system in terms of renewables, so this is the way to go.
So hybrid PV systems are the way forward. With battery storage, they can smooth out the ups and downs of solar power and, most importantly, stop too much solar electricity from hitting the grid at midday. Wind and solar are a great match. The wind usually blows stronger when the sun is weaker, both over the year and during the day, as you can see in this graphic. During the daytime, wind power is generally lower, shown here in light and dark green, and it dips exactly when solar generation, shown in yellow, peaks. You can clearly see this in the dip in the green area beneath the solar peak. Between summer and winter, solar and wind complement each other even better. This graphic shows that over the past 10 years, wind power has consistently made up a high share of generation in winter, over 15%, while in summer it sometimes dropped below 10%. Solar, on the other hand, was below 5% in winter but keeps gaining ground in summer. These opposite patterns help smooth out overall variability when both sources are used together. And as solar and wind shares keep growing, solar's relatively low contribution in winter is gradually increasing too. Here you can see how hybrid plants help ease the load on the grid. The graphic shows grid utilization in percent throughout the day. The dashed purple line represents wind power, which is lower during the day than at night. The green dashed line shows solar power. Around midday, solar output exceeds 100% of the connection's maximum feeding capacity, so the battery charges between 10 a.m. and 6 p.m. The amount of stored electricity is shown as the pink area below zero, which reduces the solar curve by the upper pink area. The resulting red line shows the total feed-in power of the system. So combining solar, wind and battery storage brings a wide range of benefits. First, better resource use. By relieving the grid, hybrid plants allow more power plants to connect without expanding the network. Second, efficient storage use. If hybrid systems can also draw electricity from the grid, not just from nearby solar or wind, they can operate more efficiently. Third, lower costs. Hybrid projects make the most of existing infrastructure, reducing the need for costly grid expansion. Fourth, avoiding curtailment. Excess electricity can be stored and fed back into the grid during peak demand. And last but not least, higher reliability. Using multiple generation technologies and storage together increases the stability of the energy supply. With all these advantages, you might wonder why PV hybrid plants haven't taken off yet. Here's Catarina from SolarPower Europe again.
So some countries it starts already with visualization of the grid. So you don't understand how much power plants of solar, wind, where they're localized, where is the big congestion of grids, where is grids being reinforced. So these grid capacity hosting maps that are lacking. We have good cases on Denmark, Belgium too. Other countries are already starting the discussion. For example, now in France regarding storage, they're starting the discussion. So I think that's a very important point. Then it's all the bureaucratic process on permitting, on grid connections. It's still very complex at a standalone project. So when you put two technologies, it becomes even more complex.
Here's an example of a grid capacity map. On this map of Denmark, you can see the main power lines, whether they run overhead or underground, and their voltages. Most importantly, it shows where there's still available capacity in the grid. Catarina also says that more needs to be done to explain what PV hybrid plants are and why they are beneficial.
Because we still have to demystify what is an hybrid system from some stakeholders that we've seen today on the conference. This is the fact that, okay, we need to learn a kind of knowledge sharing what is hybrid system, explain to people and get the awareness of what these systems are capable to do.
Of course, different countries across Europe face various challenges. Germany, Europe's most populous country, has its own restrictions that make building standalone hybrid plants harder.
I would say that is the financial part. So, for example, now I know that you are in Germany. It is being discussed that, for example, a co-located storage with a renewable system can already start charging from the grid. But if you are in a full hybrid system, so if you operate together, that's not really the case because they don't know if it's green electricity or grey electricity. Meaning, if you are paying for fossil electricity with the price of renewables. So that's the problem still in Germany. I think it's the financial of these kind of systems that still need to be taken. And then the system operators part, we just heard also on the conference, there is 800 DSOs in Germany, or around 800, maybe even more. It's very difficult to go to each system operator and have a completely different way of doing the process of connecting. Yeah. And especially for hybrids, it becomes more complex, these kind of cases.
Yeah. In fact, the UK is leading Europe when it comes to PV plus storage hybrid plants, with 62% of the country's total installed capacity. This top spot comes down to a mix of political support and smart market design, like a well set up capacity market and a CFD scheme that also covers hybrid plants. CFD stands for Contract for Difference. On top of that, simpler permitting rules and market reforms letting batteries provide grid services make the UK the most attractive place for hybrid projects in Europe. Another hybrid combination pairs solar with wind. Unfortunately, it hasn't taken off in Europe yet. By the end of 2024, Euro plus wind hybrids totaled just 555 megawatts, less than 1% of Europe's utility-scale solar capacity. So there's still huge untapped potential. As for how to unlock it, here's what Catarina Augusto from SolarPower Europe says.
So the first one, I would say, creating awareness how in energy transition regarding renewables is going to be. We definitely need an energy storage action plan to tackle all the challenge on storage, so double charging, grid tariffs. Then another thing is visualization of the grid. I think this is something we need to digitalize our grids. We need system operators to digitalize our process, have more real monitoring, have capacity maps that create a better communication between the developer and the system operator, and then all the connection process. This question of having a more harmonization, more simplification. When you don't have to have more capacity, why do we make it so complex? In Poland, for example, now a good example is that when they need to retrofit a plant, so add a storage without extra capacity, they just add an annex to the connection agreement. Very easy, just a step, and it looks just simple and easy to everyone, but it's not yet implemented in Europe. So I think it's good that we exchange all the best practices. Germany has other best practices, other countries have other best practices, so we need to exchange between each other. We need to make awareness of these systems, and then we can really step to a world that is more integrated on the electricity system.
So the outlook is promising. Grid storage has been growing rapidly in recent years, fueled by falling battery prices and strong political support across Europe. At the same time, excess solar and wind power often forces curtailment, cutting operators' revenues. As a result, more and more project developers are pairing generation plants with battery storage. In short, hybrid plants are clearly set to become the new standard for expanding solar and wind energy.